Good morning. Great to see you guys. Welcome to a stream about the Tranquility server. This is the first time in 5 years we've done one like this, so I'm excited. My name is Carneros. I'm your host today. And with me, I have CCP Explorer, CCP Paradox, CCP Tuxford, and CCP Fleabix. Great to be here with you guys.
How's the audio? Chat, how's the audio?
Yeah,
Testing.
Chat, tell us how the audio is.
Testing.
We appreciate
1, 2,
that.
3.
Testing. 5 by 5. That's pretty good.
Yay! Excellent, guys. So
And I'm loud. I'm bringing myself down. Thank you.
Excellent. So let's just take a moment and get some context here before we jump into the discussion. I want to remind you guys that EVE Online is 17 years old. We're on the home stretch of 2 decades of running this game. And CCP is actively planning new technical investment into the base technology of EVE to set us up for a 3rd decade. I don't know about y'all, but I'm excited about this. So let's talk a little bit about not just where we've come in the past 5 years since the last Tranquility server discussion, but kind of where we're going next, where we are today, and a little bit about where we're going next, to the degree you can tell us. Thank you. So obviously, a better Tranquility server means we can have more people playing EVE, and that's huge. Thank you. Recently, on the client side, we've had a couple nice improvements. We've had the memory improvements. We've had crash reporting improvements. We've had the sweet potato mode, where you can temporarily turn off 3D geometry in your client during a major fleet battle. I've used it. I enjoyed it. Thank you. But that's on the client side. Let's talk about what's going on the server side. How's the health of Tranquility?
Good. In general, pretty good. Some things have gotten better, some things have stayed the same. Alan, do you want to share on that while I start the slides? Or?
Yes, let me just talk about that briefly while you get the slides up and running. So what we want to do in this stream is to give a bit of context to what the Tranquility server actually is. We blogged heavily about this about 5 years ago in 2015 when we moved between data centers in London. But we've been pretty quiet on this front since then, even if a number of things have been happening. But the fact is that there hasn't been sort of this overwhelming change like when we did time dilation, when we moved data centers. It's rather been more of steady gardening happening in the last 5 years. And a number of things have improved. Some things have regressed. We've been adding features, but we've also been taking care of older features along the way. So with the slides up, then back to Tuxford to tell us about the core simulation of EVE Online, the core simulation of the server and where we're at. Then I'll come back and talk a bit about the hardware, and then we'll talk about the future.
Slides are up, sir.
Right. Okay. So let me just. Possibly some of you haven't seen this picture before, but it's even though it kind of resembles a coronavirus, it predates that by roughly 20 years. So it isn't us jumping on any bandwagon or anything like that. But this describes a little bit about the layout of the cluster and how the clients connect to it. So on the outer layer, we have proxies, and that's the only thing that the client actually connect to. The proxies are kind of application proxy. It's still like a server that we run, very similar to the actual simulation servers themselves. But all they do is route messages to the correct Sol server. The Sol server nodes are basically our simulation node, and they can be different depending on what purpose they fulfill. For example, the classical one is the solar system simulation node, and everything that really has to do with solar system, like anything that has to do with the simulation needs to happen on that node. So the crime watch that handles the policing the universe, basically handing out penalties for doing something wrong. Anything that has to do with calculating attributes and so on and so forth, as well as like the actual physics simulation. But there can also be sol nodes that handle any stuff within the character scope. For example, getting and fetching mail and caching it in memory to shield our very important central SQL Server database. So that's roughly the layout of it. There is some logic on the proxies themselves, but there are very few services that do anything there. One of them, which we'll talk about a little bit later, is the Bounty service. So, Alan, do you want to speak?
Yeah. So if we talk a bit about the hardware that is behind this and what we've been doing in the last 5 years, then in this case, all roads lead to the SQL Server. That's where both everything is stored. That's where the universe is stored, and that is also a lot of business logic there. It might actually be surprising how much of the business logic is in the SQL Server versus what is on the Sol servers. And as Tuxford said, very little on the proxies. It's mostly transmission there. So 5 years ago, we replaced all the hardware, but since then we have been both adding hardware and replacing it. The SQL servers, the database boxes are actually 5 years old right now, and we started mid this summer looking at replacements for them and have been testing that. And I think we haven't blogged about it, but we made the players aware of that because we had to do extended downtimes to switch to the test machines that we've been trying out. And actually, this afternoon, the DBA sent me a proposal for 2 more machines to test in January and February. This is a slow process because we can't just take hardware and test it on CC because we just don't have the load there. We're going to do some replay of startup sequence and whatnot, but ultimately, once we have a machine that we think might be a good proof of concept, we actually have to put it into production and see how it performs. So far, we found one good candidate and one really bad candidate, and that has been super interesting to see, even after 17 years, that we're still discovering how things behave. For the interested parties, we discovered that a single NUMA node setup is really bad for the SQL Server, super good for Eve. And what we're trying to now to do is to find a appropriate balance between what the SQL Server needs, which are multiple NUMA domains, versus what Eve needs, which is a single NUMA domain. Lately, we've been also rolling out older hardware on the Sol servers. The latest ones are very new Lenovo Intel machines called Gold 5222, if you want to look them up. Each one with 384 gigabytes of memory. In total, we have the Sol nodes are 35 machines, and each of them are running 8 nodes. So in total, the Sol node count is 280 nodes, and that is what comprises the computing cluster that Tranquility is. It's essentially 280 processes running on 35 machines, each with about 256 to 384 gigabytes of memory. So we got a lot of memory space. We'll talk about that a bit later, that most of Eve's code base is single-threaded per process, but obviously with 280 nodes, there is a lot of multi-processing in different solar systems going on at the same time, and we've always opted for using massive amounts of memory for caching if needed to avoid recomputation, because we're sensitive to both memory latency and CPU clock speed. The proxies are then old hardware, 5 years old by now. It's 5 machines running a total of 42 nodes, and that's where and outside that are load balancers, big IP F5 boxes, and then outside that is the network environment that Cloudflare provides us with, which then protects Tranquility from DDoS attacks. We actually changed that setup drastically in May this year, and I think the network infrastructure that we have for Tranquility is the best it's ever been in Tranquility's history. That we're completely shielded from the internet. We have a very solid network partner in Cloudflare protecting us from DDoS attacks, so that affected us greatly in January and April this year. And both with Cloudflare's reach across the globe and their infrastructure, that networking is the best it's ever been. And along with these load balancers that I mentioned, the big IP F5 boxes, which is truly enterprise class hardware, that we're running a very tight ship on that. So we've been making these kind of improvements both in the last 5 years, but also with our networking changes in May with Cloudflare, just in the last couple of months. And the current health, as I said, is software and hardware is quite good.
Let's go back to the Cloudflare thing and the DDoS. Why did you make that change in May? What?
Cloudflare was offering us a setup where they completely proxy everything. You can't access our data center in London anymore except going through proxies at Cloudflare first. So they take care of all the connection handling, and then also this provided us with the ability that we actually route traffic both to and from players through their network infrastructure. And with their, I think, about 200 points of presence all across the globe, we are now less reliant on individual ISPs and or interconnections.
Nice. Now, one of the first questions that we got asked in chat today when the stream started was, is there ever going to be a permanent solution to DDoS? And I like that, we're making improvements as it is.
I don't think there is ever going to be a permanent solution, but this is currently the top of the line solution that is available, and that is essentially having a partner that is completely shielding you, but also then proxying everything inbound, and specializing in both the network infrastructure and specializing in network defense, and we are on the inside of that protective ecosystem.
Fantastic. Have we experienced any major DDoS attempts and then gotten to see it brush off?
Yes.
Nice. Okay.
Not to the level that we've saw in January and April this year, but definitely to levels that we had seen before and had been severely affected. But they were completely brushed off by Cloudflare so far. And I'm not saying this as a challenge to anybody here on the stream to go and try it out.
Sorry, I shouldn't be smiling. I agree. Okay. So if you have to connect through Cloudflare to go look at the Tranquility server, does that make your job harder?
No,
Is it
no,
more inconvenient for you?
no,
okay.
No, it doesn't inconvenience us, no.
A lot of people, well, let's just keep going with the PowerPoint. I'm excited to talk about time dilation, as I think some people are, but I don't want to get us out of order.
Yeah, let's keep the order. So it's back to Tuxford to talk about, okay, so this is the core simulation. This is what Tranquility looked like 5 years ago. But the ecosystem, the Tranquility ecosystem looks different today. And we have some future improvements being worked on.
So in large part, it is really the same. Like the majority of the logic of of Eve is still in the Eve cluster, in the Sol nodes, and sadly the DB as well, as Alan pointed out. Less on the proxies, but still enough. But where we've been going with this is that a lot of the code that we've been writing for the past few years have really been about like these meta services. Like a market is a good example of that, where it doesn't really tie directly into the physics simulation. It isn't really a new service; it's always been there, but it's also one of the things that is just kind of you can reasonably see how it's disconnected from the actual simulation. A lot of other stuff in it, including the activity tracker, which wholly lives outside of the Eve cluster. And that's kind of where we've been going. So for the past few years, we've been creating this alternative route than the proxies into the Sol nodes and the proxies. And we've kind of landed on RabbitMQ and later gRPC through RabbitMQ. And we've been trying to kind of both develop newer features outside of the monolith, outside of the Eve cluster, as well as migrating older stuff outside of it. Currently, what we have is the Eve clients don't directly talk to these what we call domain services. You may have heard of them like microservices, but we've never really liked that name because it implies that they are somehow micro, but they don't. That's not the defining feature of these services. What is the defining feature of them is that they handle a certain domain, such as like market or bounties or something like that. So one of the challenges we have had with that is trying to kind of decouple this code that has been in the same place and can freely talk to each other for 20 years almost away from it. So what we've been trying to do is try to be really strict on the boundaries of where the Eve cluster talks to the Eve domain services and the Eve client talks to the Eve domain services. So we can really see and understand what the message is, and it really has a clean interface between them. Somebody asked before whether we're looking into changing the client to talk to gRPC. They will do that through the Eve domain services. We've talked about it for the Eve cluster, but it remains a lot science fiction at this point, really. So this is, and if you were to, like, the analogy I like to make is that if you were making a new game today, what you would do is you would likely pick an off-the-shelf game engine for it, Unreal, Unity, or whatever, or something off the shelf. But you wouldn't cram like the market into a battle server or a lot of you wouldn't cram email into the Unreal battle server, right? So what you would do is you would create a bunch of web services, and then you'd have like an alternative way to do that. And that's really where we're kind of gravitating towards, and is really what the Eve cluster was always meant to be. I recently dug up a change list from 2005 exploring these concepts. So it isn't like a new idea or anything, but it is something that the original creators, and even though I've been here a very long time, I don't really see myself as the original creator of Eve. That's the direction they wanted to take it. Am I missing something? Right. Alan, do you want to add, or Scott?
No, not me. Maybe Scott wants to chime in more on this.
I mean, actually, one of the recent features we've done was the dynamic bounty system. This is actually a domain service. This is external to the sort of Eve cluster. This is one of those features now we're moving towards putting things in this kind of Eve 2.0 or Eve 3.0 whichever version of Eve we're thinking of now, but it's the putting all of our services on externally from the monolith, so we can have just pure simulation running on the Sol nodes that we have. So yeah, dynamic bounty service is actually very recent, and it is now an external service. Something I'm pretty proud of the team to pull it off. It is, yeah, I'm pretty excited about that and the future of what those can bring.
And to continue on that is we aren't necessarily doing this outside of the kind of the Eve cluster because we are trying to make it more performant, but it's more about creating an independently ownable and deployable service which you can iterate on a lot quicker than you could do it when you are working in the same code base as 50 other developers, or however many we are at this point. But one of the benefits of doing that, as we move more stuff outside of the Eve cluster, it becomes more simple and easier to make kind of drastic changes to it.
Okay, what's the next slide?
What's the next slide? Right.
This is where we want to start by speaking about time dilation, big O notation, and sort of setting the stage for how does a fleet fight look to us, the developers and operators of Eve. So
let's jump in because there are a lot of people waiting for this section.
Yeah. So start with what is time dilation and why we need it.
Right. Do you want me to go first? Or do you want me exclusively go?
I think you should cover it.
Okay. That's interesting. Okay, so time dilation is really it's not an optimization. It's really about making, like, the best description of it I've heard is it's really about making lag fair, right? Because once the server hits a threshold where it can't reasonably process any request, the ordering of what it processes becomes, well, not quite random, but it depends on a lot of factors. So what we saw before time dilation is that people kept manually starting and stopping their guns because it would process the request faster than having the loop, like the auto repeat loop do it. And so that's the purpose of time dilation. So if we can't handle, if we can't process the request, we start slowing down the simulation until we can, up to the limit of where we have 10% time dilation, because we figured that at that point when the time is running at 10%, like the real speed, we can't reasonably go further behind that, because like then everything takes forever. But that means that when you see 10% time dilation, it may just be functioning fine and be able to process all the requests, but just at 10% of the kind of the speed that it normally does. But it can also mean that it's just completely swamped and we stopped slowing down time at 10% and it can't process the requests in time. And that's when you start seeing a lot of these latency indicators, for example, your modules kind of overrunning and stopping at way after they should have stopped and so on. So here, what I have shared now is kind of an overview of what we see when there's a fleet fight. There's a bunch of things. We don't only look at CPU times. GPU graph is actually kind of boring. The time dilation graph is kind of boring as well because it just sticks at 10%. CPU sticks at, well, it should stick at 1, but there's some weirdness factors where it jumps up to 1.5. It doesn't mean it's running at 150% CPU. Some of the things that we look at, for example, is this is SPF. It's basically roughly frame time. You can see it's barely noticeable before and after, but then it kind of jumps into the 500 millisecond range, and that just means it's taking longer time to process each chunk of work. Another graph that we look at is the runnables, runnable 1 and 2. It basically means like how many tasklets do I have scheduled to run at the beginning of the frame and how many did I run the last frame. The runnable 2 is, runnable 2 is of importance here because that's really what decides on what the time dilation is. So it's basically, that's what detects if it's running behind in the simulation. And that's what triggers the time dilation. This actually used to, I don't remember if a lot of people experienced a lot of lag some time ago, like some years ago, where there was no time dilation, but there was like severe latency in all the modules and stuff like that. So, and we saw that as the server in 100% CPU and being slow to process requests, but actually not triggering time dilation. And that's because the only thing that was happening was the reactivating a module, and that was all a single tasklet. So it never really had a tasklet waiting for it because it was just one tasklet that was running behind. That's been fixed for some years now, but it kind of what showed me like, oh yeah, it's not looking at CPU, it's looking at like how many tasklets does it have yet to process. Erlendur, do you look at these graphs? Do you guys want me to talk more about time dilation specifically, or?
No, I think this covers time dilation pretty well. I think it's one important thing to note as well is that when you're in a fleet fight, you need to be notified of what everybody else in the fleet fight are doing. You know, who's moving, who's shooting, where are the drones, and so on and so forth. Your client needs that information from everybody. But everybody else needs, so essentially everybody needs information from everybody else. And that means that big fights scale like n over n squared, with the n being the number of people that are present in the fight, because everybody needs information on everybody else. We can often see this in CPU graphs and traffic graphs, and when we look at the number of messages that are being passed around. And this is what makes large-scale fleet fights so tricky, and this is why we've had to put a lot of effort into that over the past 17 years. It's simply this scales quite badly. This doesn't scale linearly with the number of players, but rather it's I wouldn't say exponential, but it can become quite tricky quite soon. So during a fleet fight, these are the kinds of graphs that we will be looking at. You know, what is the CPU? Well, it's usually 100% in big fleet fights. And by the way, this is a graph from a Guinness World Record breaking fleet fight where you, the players, set 2 Guinness World Records in the same fight, which does go to show that the health of the Tranquility cluster is good. It is better than it was when the previous 2 records were set. And what I've heard from players from this fight is that it was time dilated and there was lag, and it took 14 hours, but ultimately it was from players who had been present in the previous fight, it was better. Now, we're not saying it's perfect, but we're constantly looking at what we can improve and what we can fix on this front.
Okay, now we've talked about time dilation, and I've heard that time dilation works differently when you get to the 10% threshold. Can you explain that for newer players?
Yeah, so once we're at 10%, we start entering kind of the realm of the server being completely overloaded, which means that it has a backlog of stuff to do. So it may respond to some of your requests really quickly, and some of them may take a long time to come back. So the fact that we are at 10% time dilation doesn't necessarily mean that something is wrong on the server, but you may start feeling like a lot of like latency indications. modules being slow to deactivate and activate, and so on.
Okay. What is it that when you guys hear there's a major fleet battle happening and you guys go to look at Tranquility, what do you look for first, and what do you see? You see this chart right here, right?
So yes, we do see these kind of metrics. We have other metrics like how many people are on the node and so on. This one is missing, for example, how many people are in space on those nodes. We can also look at a more detailed kind of telemetry of what the nodes, so like actual function calls and how long they're actually taking. There's a bit of an overhead to it, so we don't really do it if we deem the node in because we too bad state, because we don't want to kind of push it over the edge. So yeah, those are some of the things that we look at when there's a fleet fight.
Now, very often we will first know of a fleet fight when we get a fleet fight reinforcement request, which will be then a day or two before, or maybe a couple of hours before downtime, and that's where obviously our community team is very aware of what is happening in the game and in contact with players, so we will get heads up on what is the overall buzz and activity in the game, but then formally what we often see as the first indication is a fleet fight reinforcement request. And I saw there was a question in chat on what happens there. It is simply that we then move the solar systems that where the fight is going to take place, or where there is going to be staging involved, to dedicated machines. Now, they don't go to any better hardware per se. They go to the best hardware that is available in the cluster, but it's not like we have a water-cooled high-performance computer somewhere in the corner. It is simply that we isolate the solar systems away from others. By comparison, on average, each node in Empire is hosting about 25 solar systems, so it's simulating on average 25 solar systems at a time. For a fleet fight, we will have individual machines for the individual solar systems to offer the best performance that is available.
Okay. Now, I've heard people mention big O notation. Can you explain that part?
In the computer science term.
Yes.
Yeah, I studied engineering. I don't know anything about now. It basically is about kind of how a certain algorithm scales. So with size. So for example, and by cutting out all the kind of the constants and stuff that don't really matter when it comes to the scaling of it. So regularly what you see is like ON is the best case scenario, that it just kind of scales linearly with size. N squared is where it kind of squares every time you double the sample. And that's what Erlend was talking about regarding the communication between the clients, or not the clients, the communication that needs to be sent from the server when it comes to and it's just a kind of a method of saying like how does this algorithm scale when it comes to memory or CPU.
Okay, so let's talk about player bounties for a moment. Did you show that graph where the thing dropped down?
No, but here is like from that fleet fight. If I go way back into my original first slide here and explain a little bit about the bounty system. So I said like some services are like the solar system service, and they're the simulation for the server. one of these services is the Bounty service, and it runs on it's more or less on its own node, right, Explorer, now?
Yes, we isolated it a long time ago because of the effect that we saw during fleet fights, which you're going to demonstrate on a later slide.
Yeah. So so the calls to getting the bounties goes to an entirely different node than the rest. And so this is this is the graph of like that view where we have, and we can see that it's really overloaded. It's the CPU is 100%. Time dilation doesn't make sense there, but you can see it as well from the DB writes when it happens, that it has to do less DB calls because it has all the calls that it's getting are getting stuff from memory. That's the majority of the calls it gets. But you can also see from the where is it the SPF, the frame time, like how long, how much that increased. We're seeing frame times up to 300 milliseconds.
But to emphasize that this is the client is asking for this bounty information. It goes to the proxies. In many cases, it will get returned information directly from the proxy. But if the proxy doesn't have that information, it is not going to the location node where your fleet fight is happening. It's going to a different node in the computing cluster and asking for that information. So when we turned bounties off, it didn't have an effect on that location node where the solar system was being simulated. It had an effect at a different place in the cluster.
There's one risk I'd like to mention that I hope is okay. But if we were to overload the bounty service to the point where it would actually crash because of it, it means that the bounty service would get mapped to a different node and would then continue on killing that node and would become this roaming death service around the cluster and kill nodes until nothing was left. So in the past, we've sometimes turned that off just in case we get this roaming kill service, but I honestly think that it would never be able to handle all the network requests to put it into a mode where it would actually miss its heartbeat and not be able to do it. But I really don't often want to take that chance. Did I share any secrets, Explorer? No?
No, I don't think so. But then, Paradox, you can maybe talk a bit about what led to the decision of the current experiment that is ongoing, because we've turned player bounties off since for a month and a half now.
Yeah, I mean this has been a continuous request, I guess, from both the CSM and players, in that during a pretty intense fleet fight, one of the only things, apart from some of your module activations, that players can actually see through the outstanding calls window in in Eve's internal sort of tools, is the outgoing calls for a bounty, of just the server responding to that. And sometimes players saw this for 20, 40 minutes maybe, and is frustratingly one of the only indicators of whether some of your events get processed. It's slightly, because of that, because it's one of the only things, it's slightly a placebo, but it is part of both the requests and sort of information being sent back to clients, especially the n-squared amount of clients that you have in a fleet fight. So a lot of some of our internal discussions at CCP this year is just being to do some stuff and learn from it, actually learn from some experiments. And we decided we actually have some of these switches already in place. So why not just go and flip a switch right now in one of the most sort of war intense moments of previous years, and see what actually that has, because we have a really good opportunity to see the data. and we started seeing data. We started seeing something come in, and I think actually, basically, CCP Tuxford has some of those graphs already that what we can watch.
Yeah, so this is about what the proxy is sending, all the graphs, all the messages that the proxy sends, and you can see it drops by, I don't know, to 2/3 of what it used to be here. If I recall correctly, we didn't really see a noticeable drop in CPU though, did we?
No, that's the thing. That if you look at this graph, then you can see it sort of tops out at 60 M. So I think this is measuring the number of packets that is being sent, 60 million packets, if I recall correctly. And you can see there are big spikes there on the weekends when many of the fleet fights take place. So it drops from sort of a top of 60 to 30, and it's much less spiky than before. But we didn't really see any change to proxy CPU or latency or anything like that. But obviously, as Paradox was explaining, you see an effect on the client in that your outstanding call list, if you're running that debug tool, will be shortened. Now, this may look like a dramatic performance improvement, but that's your cue, Tuxford, to move to the next slide. The fact is that we had long ago made vast improvements to the number of messages being sent by the proxy, and you can see, if you look at the tiny dip at the rightmost end of this graph, then you can see where we turned the player bounty system off as an experiment. But in early 2018, we moved chat off the cluster to an external service in Amazon, and that's where we got the biggest benefit in terms of traffic on the proxies in the last 10 years of EVE. So it's very difficult to make further improvements to the proxy. They're always going to be dwarfed by the immense optimization that we made when we moved chat to an external service.
Yeah, that's a dramatic slide right there. Thank you. I wanted folks to see that. Okay, so in yesterday's patch notes, there was a line in there about a super weapon change in. I can read it to you exactly. Actually, can you explain that? Here, I'll read it to you. Oh, it was in the patch notes. Hang on.
So I think it should read something similar to that we improve the stability of damage over time super weapons to make them more reliable at applying their full damage under heavy loads. Should be about word for word, I think, for that.
Did you write it?
No. But this is something that we saw recently with particular fleet fights. Was a particular tactic used for the super weapons under pretty extreme circumstances. And for this, we had seen some errors and we had identified some critical points of failure. But this was present, I think, since we first introduced the revamped super weapons back in 2016, I believe. And this kind of super intense fleet fight we've never seen before. We hadn't had the numbers. It was pretty high in player number and player attendance, and it was definitely a situation that we hadn't seen in the last 4 years since introducing this. But we did identify several points of failure that we could see these basically two parallel conflicting tasklets in code could sort of, I guess, intersect or interact with them indirectly and cause a basically falling over of a rock and just tripping up there. So we made a very targeted change to improve that. However, where any other issues lie, we cannot tell internally. We cannot throw 6,000 people at a mass test. We don't get those kind of numbers. And the amount of human interactions that happen during fleet fights will just far outweigh anything we can automate with any kind of thin clients or proxy clients that we have at our disposal. So we really hope that we've resolved the issues around this, but whether something else lies around that, we don't know. But we took some time at looking around that particular area of code, so basically these two task lists that intersected, and I think we're hoping that that resolves the issue for now.
All right. I'm looking forward to trying it again, but thank you. Cross my fingers. All right. Have we gone through all the slides?
There's one left, which I don't know.
I think it's actually applicable because we've been asked in chat, why don't we just move wholesale to Amazon and start up a couple of EC2 instances and be done with it. And it is not that simple.
So yeah, it isn't. And I saw also in chat like the Amazon SLA is like 99%. So, but that's not really our problem. Our problem isn't really keeping the hardware running. The hardware actually runs all the time. This has to do with being a kind of an old game where we've kind of cemented the whole idea into the downtime in multiple places. So this slide I have now is basically showing the growth of lines of code by file type. So it's split up into multiple phases. That's mostly I was gathering this data for a different reasons, but basically each segment is a point in time where we were in a certain depot, like a source code, like we've moved our code base around a bit all the time, and it's missing a chunk there in the middle. But it shows how much the Python code has changed and how compared to the C++ code. So Python is fantastic, but it doesn't necessarily drive you towards making like a decoupled code with clean interfaces. You basically have all the rope you need to hang yourself with. So over kind of the course of almost 20 years now, we've been writing code majority in Python, and that's why, like, when you say like why can't you just make Eve multi-threaded, and it's not so easy as to press a button and go into multi-threaded mode. There are assumptions all over the code base that these things need to happen in this order, and you can't really come in between that. It's also in some places like a bit tangled. It's been, I don't want to be too much doom and gloom here because it has really been trending in a better place over the years. So lines of code don't tell the whole story. So you also have to look at like how well written is the code as well. So and all of these things make it harder to do things like, well, let's just move it to AWS, let's just make it multi-threaded, let's write it in a new language, and all that stuff. Every time we take a chunk out of the Eve cluster and move it outside of it and reduce kind of the scope of the Eve cluster, it makes projects like that a little bit more viable, and that's kind of the general direction we're heading and been investing a lot in. To Randy, makes sense.
What code did we delete there? Yeah.
I haven't taken a look. It took a while to get this data, and I abused the hell out of our peripheral server probably, but it may have been removing some old dust code that wasn't needed.
Okay.
And I believe some of these drops are not for any specific, like, because I did this very naively, I just counted the line length of the file, but that doesn't necessarily mean that all the lines are code. For example, we used to decorate every function with like 3 lines of code. So when we deleted that and just adhere to the PEP8 standard and just put 2 line spaces between the or 1 line space between the functions, then that would have kind of deleted a lot of lines.
Yeah.
Just put a knife through the heart of the Dust players.
Sort of all the topics that we had prepared, so it's question time, I guess.
There was a question on gRPC. I wonder if you want to go into that a little more detailed.
Well, I mean, not too much, except the new, like, for all the newer technology bits, we are moving into that direction. Not quite there, but any day now. But for the kind of the foreseeable future, the Eve clients will still talk to the Eve cluster through our very own.
We had a small server cut on the Twitch side, so they lost about the last minute of your talk, Explorer. But we're online again.
We're online again.
Oh, thank God that was cut out. What do you?
Wow, all the stuff you just leaked, man. Well.
Okay. Where do we need to start again?
The secret stuff that we were talking about.
Yeah. Anyway, short summary of the last minute or so. There have been a lot of discussions happening on replacing the older network infrastructure with gRPC, and obviously what we want to do is to have the client connect directly. If you move to the second slide, Tuxford.
Yep.
This one, yeah. Obviously, what Tuxford has been speaking with the tech director of infrastructure, Chimichanga, that we want to have the Eve client connect directly to the domain services using gRPC rather than to have to smuggle them through the cluster like we do at the moment. But then ultimately maybe replace the entire infrastructure with gRPC. But that is not, as you saw from the code line graph, that is not as simple as, having a month's downtime and looking at the code and just rewriting or, automatically transferring to a new system. Which is why this is more of a continuous process, something we've been doing for the last 17 years, and in particular we've been focused on both new feature development, focusing on new players, but also attending to the veteran players and to the general health in the last few years.
All right. There was a question about why aren't more calculations handled client-side to avoid using more simulation time? Is there a bigger benefit to doing everything server-side?
It's most...
You never trust a client.
Yeah, it's most
simple as that.
Trusting a client.
We do an enormous amount of calculations client-side. For example, it will do the complete physics simulation alongside with the server, but the server is completely authoritative on what is happening. And it will do a lot of these things sort of to keep the visuals smooth, and it will cache things and it will get raw data and do a lot of the processing on that. But ultimately, we don't trust the client like Paradox said. So ultimately, the server needs to do all these calculations and hand off the correct information to the clients.
Some of the very visible services that you have are, for example, the attribute modification and effects that you have for your ship health or the amount of damage you do. There is client-side calculations for that. For example, that's one of the biggest ways of how we're able to do ghost fitting with some of the rework we did around that client representation. But at the same time, the server will always tell the client what it actually is, especially if it goes slightly out of sync, or if you attempt to in any way convince the client otherwise of your values.
There are kind of the ideas like trust and verify and having like a consensus on things, but those are all kind of complex solutions that we haven't really dove into.
I'm not sure.
Any other questions, Carneros?
Not sure if I'm allowed to ask some of these or if they're sensitive.
We can pick hearts.
The worst case scenario is we would just simply say we don't have an answer or we can't answer that.
We'll just cut the stream again, right?
Perfect. The charming and talented Dr. Spadmane asks, are there any news on the in-browser game experience? No idea what he's referring to.
Is he talking about the first session in browser?
Probably rather than the in-game browser. So it's the experiment we were running.
Yeah,
right.
I don't have any particular comments on that. It's
no, me either.
Okay, all right.
Nope.
We'll
dropped off again.
Okay, next question.
We
Can solar systems move between servers to relieve one of the servers?
They can sort of, yeah, they do, and we do map things live, but it involves disconnecting everybody currently. We've had a lot of talks about like, well, okay, can we put the time dilation to 0 and then kind of migrate people over? It's all very cool, but you know, we haven't really put a lot of effort into exploring that.
So it's all very destructive at the moment. We can easily move them, but everybody gets disconnected.
Usually what we do when we're doing this is that we move all the other systems out of it. So if there's like already a fleet fight happening somewhere, then everybody else is moved, right?
Yeah. That's the tactic that we have. If we don't get a fleet fight request, we will essentially anybody who is not involved in it, they get the short end of the stick. Sorry.
Okay, that's fair. Another question from, well, actually, this is more of a request for comment on an idea from Glow Hollow. What if the Eve cluster only gets a, quote, video cam from the Hadean engine and send a stream to the clients? What about that idea? Have you considered that?
So it still involves like a lot of changes to Eve. Basically, you basically have to re-implement Eve in a different system. So we've entertained similar concept, not necessarily with Hadean, but yeah, it's. And again, I want to point out kind of the direction of where we're trying to simplify the simulation bit, so we can actually move forward. Like we will move forward with it regardless, but it's like both things. Let's move all the stuff that doesn't have to do with it, as well as kind of strengthening the boundary of the simulation with all the other systems.
Okay. What is the, and this is from Bergerman, what is the scope of a big fight when it comes to server load and tie-dye activation? At what point does the server choose to move over into the realm of what's a big fight?
Are we talking about player numbers or activity?
Okay.
So
Go ahead.
If you're talking about like when does it hit like time dilation or something like that, then it really sort of depends on the fight. Each fight is kind of unique. It depends on what people are doing, what they're shooting at. Some things are more expensive than others, but yeah, I'd see anything above 100 is probably like a sizable fight, which should still be like a fair, and anything over 6,000 is really, really big.
It depends so greatly on the activity. Using a non-fleet fight example of JITA, when we released the last monthly deployment, there was a big update to JITA 4.4, and we immediately noticed a lot of abnormal CPU activity compared to the number of players in JITA. Obviously, what we saw was a number of people who went to JITA to redo their Insta undock bookmarks and to take a look and whatnot. But we noticed a lot of abnormal CPU per player in that system, and the reason was instead of people being docked in station trading, they were actually outside warping back and forth and or orbiting the station. So we could correlate the CPU increase with the active players in space compared to the normal pattern in JITA, which is people docked in station. So it depends greatly on what you're doing, what is the normal pattern in a particular solar system, whether you are in Empire where Crime Watch is continuously running with both Concorde and Gate Guns, or if you're in Nullsec where there is no Crime Watch because it's not needed, because it's the most safe space.
Thank you.
Turns out scamming people in local isn't really CPU intensive.
Especially if you don't undock.
Yeah, exactly. If you're in station and it's just from the chat client from the chat cluster to your client, then it doesn't even touch the location node.
And some of the scams don't work if you undock. You have to be there to trade with the person.
I wouldn't know.
Oh,
Yeah, you would.
I've heard rumors.
Yeah, we've heard rumors.
Double ISK Tuxford.
Completely different question, unrelated to the Tranquility servers at all, but Sedated Rooster asks, are you guys considering an Eve Classic server?
No.
I used to play Eve back in 2003, so I don't think it is as fun as you think it is.
Exactly. All right, thank you. Okay, so AxMe24 says, have you thought about going back to old mapping of solar systems to nodes that did not map geographically close systems to the same nodes? So there was a lot less lag when moving fleets around during those days.
Yeah, we have thought about it, and we may in fact do some experiments on this in maybe in January and February. So currently, to answer this question and the questions I've seen in chat, we map solar systems onto node with the locality in mind. So solar systems that are connected with stargates, they tend to end up on the same node. So there is a lot less internode communication, but a lot more intranode communication. But there are rumors that this tends to cause lag when large fleets are moving around, and in the spirit that Paradox mentioned, that we're doing experiments on these kind of discussions that we have been thinking about doing an explicit experiment on this in January, February, and see if and preferably what I really want to do is to do it at a time without telling people, and see if I get the response from players where they tell us that something changed. without actually priming them with the information that we did make this change. Obviously, for the player bounty experience, we needed to tell people that we turned off a system and what was the expected behavior and so on. But I really want to do this remapping experiment early next year without explicitly priming people's expectation and seeing if there is if there will be a buzz around the time when we do it.
Roger. Okay. Okay, Jotun050 asks, can't you decentralize some of the server calls, delegating them to the client? Something like doing work on the client and send the server a promise that the result will be available when needed. I know we already talked about distrust for client side. Is there anything you want to address about this?
This would be one of the kind of the method of trust but verify, right? So we have the client calculate something and then we can have an easy way to verify it, but we haven't really dove into it. Usually these solutions are a bit more complex. I'm not a fan of complexity when it comes to software, but the optimization may very well be worth it.
I think like this in particular comes down to the idempotency in computer science. It's one of the more challenging aspects of authoring for server to client communications. I don't envy any engineer's task for looking over that, but it is in no way a easy task.
Yeah. Folks in chat, I'm going to ask you to be patient with the questions because there are a list of them here. RG Quendon asks, with the load testing, can you not simulate relative server load by speccing down hardware, such as Thunderdome CC entering tie-dye earlier? Or is the load very much different and you really need the bigger scale?
I see what you're like, but with the right. So you're asking like, can we just use worse hardware and to trigger the load faster, right?
Yes.
Yeah. Okay. Yes, possibly, but also some of the load comes from the algorithm as such not scaling very well. So it would be dependent on how many we are, but we need to start investing more in kind of reproducible scenarios where we can run these kind of simulation on a larger scale in order to make sure we don't regress and make sure that or to be able to add more fidelity to the simulation without actually sacrificing too much performance. And yeah, does that make sense?
Okay, yes. All right.
And just to add to that a little bit, we do have options with us that like bots, lightweight bots, both like full-scale client also as well as thing we can run on the proxies that simulates a bot or simulates a player, right? Multiplying your own bots.
Okay. I get nervous every time you say the word bot. Okay, Rizio Typho asks, when will the next downtime experiment be? Meaning attempting to get rid of it or shrink it.
Oh, so one of the bigger issues we need to fix with this is the fact that the clocks on the proxies and the sol nodes drift a little bit. Right, so they get slightly out of sync. We do synchronize the hardware clock, but the clock in the simulation is just like we just take the timestamp at the beginning and then they independently tape to it. We've messed around with trying to change it, adjust the clock, but it's very hard to do for a live simulation because time can't go backwards for such a system. But this is one of the areas we need to explore because once the clock starts going out of sync, you start seeing very kind of latency behavior. Even though it isn't latency, it's just that the client thinks things are happening at a different time than the server does. And I really like to fix that before we move on to the next experiment with no downtime.
And then we also have game features that rely still on downtime or on server startup, like asteroid reseeding happens during downtime. This was these kind of issues, and these were probably the two main ones that surfaced out of that experiment. There was the clock drift became excessive, and obviously on the second day there were no asteroids. These are the kind of issues that we really want to try and address before we do another experiment, because if we don't address them, then we're just rediscovering the problems we already know about.
I love it. Thank you. Okay, another good question from Axme24, whose name for some reason amuses me. Is the proxy traffic actually relevant to tie-dye and issues in big fleet fights? You should be able to scale extra proxy servers without any issues. In that case, why keep chat in the barely working AWS cloud instead of keeping it in the same location as the rest of TQ? I apologize for saying the words barely working.
Well, I mean, I would say it's slightly more than barely working, but yes, certainly we've had issues with it, and we're not gonna deny those. But we are, however, working on improving those. But to answer your question, then the proxy, like the amount of calls on the proxies have nothing to do with time dilation. It's wholly decided by how if it's running behind on the tasklet that it has scheduled. It's interesting that you say that you can add proxies without any problems, because I am less certain of that.
So one of the features or one of the aspects of the cluster is that it's a full mesh cluster. Again, O n squared, that every node can speak directly with every other node. There is no routing that needs to go. If node A wants to talk to node B, it doesn't need to go through any middleman. All the nodes can communicate with all the other nodes. If you add more nodes, then the number of connections increases n squared. So adding nodes, is doable, but can be tricky.
Okay, Bubble Pones asks, are you able to record and replay large or small fleet engagements for further analysis back in the labs?
No, I'd wish. Yeah. No, I mean, we've thought about such a tool, but everything is still so dependent on a client connection and all that. So it's such a large, complex ecosystem. We've thought about it in terms of, and we do have some of these things to play out scenarios for the client itself to work on that, but not on the server.
There's a lot of fighting happening outside right now that you can't see, but it's good. It makes me smile. I wish I was in fleet. Okay. So the Viking Bay asks, going forward, what does the roadmap look like for improving the server's support for large-scale fights? Are you allowed to tell us anything about the future? And or you've already touched it as far as you can.
I don't think I want to talk about anything until I have something more concrete, if that makes sense. But I do like to point out, like, creating an environment where we know how the cluster performs before we have a big fleet fight is vital in that respect. Like, we can't rely on you guys having a 6,000 people fleet fight in order to see if we're making progress or not. We need something a little bit better than that. And that means investing in, which isn't really super exciting for the players, but it just means that we have a more sane foundation for making changes.
Okay, another Ask Me question. have you thought about using VPNs and incoming servers positioned around the world piping into TQ as a DDoS protection, presumably instead of Cloudflare? Would allow for a lot more geographic filtering instead of having all of the world connecting directly into TQ. Could improve latency for some people.
Yeah, we at the time when we selected to go with Cloudflare, we were having meetings with companies that provided such services. But in the end, we decided to go with Cloudflare and a full proxy, because then we're only receiving legitimate requests anyway. And given that there is little processing that is happening on the proxies, it didn't make sense for the current code to distribute that geographically.
Thank you. Okay. Dr. Spadamane asks, are you seeing any performance differences with the protobuf migration?
Performance. Oh, so we are. We've been doing a lot of improvements with the protobuf marshalling, really. And yes, we have seen them. You won't necessarily see them in large fleet fights because it's more of a, it wouldn't affect you in those kind of terms. But it does mean that we can turn on a bigger fire hose of events, for example. I don't know if you, I'm pretty sure we've talked about it, but at some point we were sending out events for every single shot fired, every missile launched, every turret fired. This did have increased the load significantly in fleet fight, so we just basically turned it off because nothing was really listening to it. So, but we're now in a better position to actually do that, and that means we can start offloading a lot of like the auxiliary, but still kind of simulation services, such as like the kill mail generation and stuff like that. And to some effect, the dynamic bounty system, although I do believe that this is probably more to the bounty payout rather than anything.
Okay, Abathur Warfield asks, will CCP in the future look at hardware like Cerberus WSE? Which I'll admit I don't know what it is, but might be good.
Pass.
Pass. Okay.
I'm going with pass on that.
Sorry, you guys are getting me in trouble.
Yeah.
Okay, Plaid Rabbit. Hello, Plaid Rabbit. Good to see you, guy. Asks, with the way the client server works, does the client have to process the messages from the server in sequence, or does the client support like out of order processing?
So it does have to process like the solar system updates in sequence, and it does that. And it's actually the same thing. The messages about like attribute changes, it does that in sequence as well. But the rest is kind of they can arrive out of sequence.
So, for example, if you're orbiting somebody and shooting at them, but also viewing the market or working on a contract at the same time, unlikely scenario, but could happen, then everything that is happening in the simulation needs to be processed in order so that the client and the server agree on what is happening. But the rest of what your client is doing, like the chat messages, contract markets and whatnot, can happen in any order, so long as it makes sense, but doesn't have to fit in with the solar system simulation. That's where we have strict requirements on it. Also, all inventory operations, if you move a thing from A to B, it has to be correctly removed in one place and added to another place.
Although I may be lying to you guys about this, but I'm pretty sure it can receive them out of order, but it will process them in order, for example, for the simulation. And actually, the simulation won't progress unless it's received the package it thinks it should get.
Yeah, doesn't it even when it gets severely out of order and feels it's sort of missing packages, it will ask for a complete refresh, if I recall correctly, as a part of a desync defense.
Under some scenarios, but also sometimes it just stops and just doesn't process anything, which is the worst case.
Yeah,
it's a very difficult thing if you drop, like if you have a mechanism that refetches the state again, it can also make things worse, right? Because if this happens to a bunch of people, and that's why they're missing packages, and everybody starts requesting everything again. So you have to have a very kind of sane backup strategy there as well.
Okay, here's a question that a few people have posed somewhat differently in different words, like Circadian Seeker and Elise, I'm watching you, Elise, asked, are different weapon systems or activities more costly to the server than others, like a drone fight compared to a missile fight compared to guns, for example, given the same number of players?
I think I partially answered this to somebody who was asking earlier in chat, but at least for missiles, they are actually real items. They actually, when they're fired, they exist in the world because they can be destroyed, and when they explode, they leave. So all clients and the server need to know when missiles come into play and are seen, which is a little different for shooting a laser, for example. The actual performance cost is very dependent on the scenario that is out there. So it's really hard to say one pit, like somebody can make drones really look bad if they throw lots of numbers on that, which players are well known for, of just throwing the just human resources at an equation and getting away with seeing how it reacts. But yeah, I think missiles is different than a lot of the other weapon systems.
Roger.
Yeah, so missiles are, yes, they are actual items that are tracked through the simulation. But I do want to point out, Scott, they are literally called fake items.
They're actually, I was going to point that out as well. They're literally
But
real fake items,
yes.
as opposed to real items, as opposed to lasers who don't exist as items.
They don't persist in the database.
Yeah,
Is what we mean for fake item.
Exactly.
And then
their
there is
presence
always
has to be broadcast to all clients, and
And the same thing goes for drones, for example, and fighters, whereas, for example, fighters will have more logic because they can actually, they can do more things than drones can do. So, yeah, there is a difference between these weapon systems in terms of their complexity and what they're capable of, and that obviously translates into processing cost on the server.
Thank you. Okay, Rain asked a question going back to the DDoSes you mentioned earlier in the year. Do we know if those were done by players?
I can't comment on the investigation.
So desu ne. All right, thanks. Good try, Ryan.
Actually, for bringing it back a little to weapon systems, we have one of our most senior QA at the company who often is at the forefront of looking at server and client performance, CCP Habakkuk. He was been following a thread recently with a lot of the fleet fights and has found some issues surrounding smart bombs. And also CCP Cognac, a shout out to him. He managed to determine the fix and has an improvement to smart bombs coming up in this December in terms of server performance. I don't know whether I should share the expected number because it's an extreme number in terms of how much faster we expect this to be for the server, but it's definitely going to be really interesting to see what happens. I don't know of any upcoming fight that might use smart bombs as such a tactic, but hopefully when they are done, that we can take a look and see see sort of some of our observations beforehand to how they are post the sort of December update.
Okay, I'm going to paraphrase the next question somewhat to make it more politically correct. It's budgeting season for 2021 here at this time of year. If CCP suddenly gave you a huge amount of money and said, throw this at the Tranquility server, what would you do next?
So it's my opinion and Explorer's opinions and all of the basically technical leadership, and that this isn't really something that we can make drastic improvements by getting better hardware. And part of that is, or majority of that is, of course, that it's a single thread application. So what we need to do is to invest in the software and the people then. So, and that's not going to be like an instant. Like for the longest time in CCP history, we used to be able to buy ourselves like a better performance, but we can only get so much. CPUs aren't really getting faster. We are getting more cores, and sometimes at the cost of clock speed. So, yeah, I would.
But this is what we have actually been investing in and will continue to be investing in, and that is to move some of that processing somewhere else. Because currently the simulation is so dependent on clock speed and on memory bus bandwidth that we need to move processing off to make use of more cores, but that is not through adding multi-threading or adding more nodes, but actually moving some of that processing into the cloud where it's separate from the rest and doesn't need to run in the simulation, essentially slim down the simulation as much as possible. So if we had an endless amount of money, that would be more people to take a look at the software, improve the software, and do these things that Tuxford actually spoke about at the beginning of the stream. How we're transitioning from the Tranquility like it was in 2015 to what it is today and what it will be in 2025.
Okay, there's an ongoing. I don't know if it's a discussion in the player base that you may get an advantage if you're living in the United Kingdom, where you're close to the Tranquility servers. And there's a question posed by Jimmy 20006 about that. Is there a benefit, or is that benefit mitigated by Cloudflare, for example?
I mean, obviously, being close to the servers, there is benefit of it, but also Eve isn't that kind of game where that matters so much. Like it matters to some degree, and I'm sure people in Australia probably agree to that it matters a bit. But it's not such a huge factor as in other games.
So I think it's a yes and no answer to this question. Cloudflare, I think the network infrastructure they have has improved the things a lot. But as Tuxford was explaining, Eve ticks at 1 hertz, so it's ticking once a second, and there is certain gameplay like insta-locking is very difficult if you live in Australia. If you live near Heathrow, it's going to be easier. But not a lot of gameplay depends on this, and in fact, none except insta-locking should depend on this. But ultimately, yes, all roads lead to London, and there are physical limitations on how fast we can bring a message from Australia to London.
Except by drilling straight through.
Yes, yes, we could do that.
Okay, adding that to the list for 2021. Okay, Rizio Typho asks, how much of the state of a solar system is stored on a proxy?
Nothing. There's nothing stored on the proxy. Well, no, not the state of the solar system. We do.
No, the state of the player, though.
Yeah, state of the player is somewhat. It's hard to say how much, but.
Okay. Dr. Spotamane is asking what the rough specification of one of our biggest, baddest server blades might be?
So I'm just pulling it up to make sure I have the exact. So the fleet fight nodes, JITA and other systems that have a high activity on a routine basis are running on Intel Gold 5222 machines. Those are dual core, dual socket quad core machines. So it's 8 cores or 16 threads per machine. They have 384 gigabytes of memory, each one of them. And I think we have 5 machines like that. Then we have 5 other that are 5122 Lenovo Intel machines as well that run other services. So 10 out of the 35 machines is the sort of the top of the line that Lenovo and Intel have to offer. Now they do offer faster machines and better spec machines, but not in the flex chassis format that we need for our server hardware. We've taken a look at better hardware that they have, but Lenovo and Intel don't have a handle on the thermal output of those processors, so they're not available as blades, but rather as 1U servers with lots of fans and cooling, and we can't use them in our current setup. But Intel is scheduled to have processors that are similar, where they have gotten a handle on the thermal output of those processors next year.
I guess that's why we have FanFest. FanFest.
I hope we have FanFest. Dude, bring up a sore subject.
That's why we have FanFest. That's the cool of Tranquility. Yes.
I may not say much on
Jesus,
servers, but I just
Felix.
bring it in.
All right, we're starting to wind down on questions now. There are a few in the queue, but we're not really going to talk about low set gates to stain and things like that, guys. Sorry. I know you're probably playing some kind of bingo and needed us to mention it once, so there you go. Okay.
No more questions?
Well, looks like it. There are a couple people who are inadvertently asking things that are too close to secret subjects, so no. All right, thank you. Guys, this has been fun. We need to do this more than once every 5 years.
Absolutely.
But I just want to take a moment and take in the fact that EVE Online was a pioneering game when it came out in 2003. And it continues to be a pioneering game today. And I'm astonished at the potential it has for the next 10 years. And thank you. On a personal level, I look forward to playing EVE as my retirement plan once I have retired from work.
The plan here is that EVE will be forever. It will outlive us all. So we're just trying to make that happen.
Amen. Thank you guys for joining us for this special stream. Is there anything else that any of y'all on the panel want to say before we go?
Keep pushing the server. Keep having big fights. A lot of activity happens when we start getting really good data coming in. Super cool for us.
We do have something coming up next, so don't leave us yet, folks.
Absolutely.
But I want to say thank you to CCP Explorer, CCP Paradox, CCP Tuxford, CCP Fleabix, who's in addition to everything else is running the stream in the background. Thank you, sir. I
Not
want to
just
thank
jokes.
the ISD volunteers for moderation. Less thanks from Moobot, who's a little bit heavy-handed. But yeah, thank you guys. The ISD team is looking for volunteers, by the way. I don't know if I can put a link in chat, but I'll try.
Are you trying it now?
Yep, I did. So if you would like to be an ISD volunteer, please click on that link and read that. We are going next to Talking in Stations for a discussion on these same subjects, hosted by Matterall and Elise Randolph. You ready, guys?
Am I the guys or Talking in Stations the guys?
That would be you.
I am the guys.
Talking Stations is ready.
All right.
Let's rate them.
Let's raid them, guys.
I just want to do
thank you again, everyone.
a couple of plugs before we leave. So tomorrow we have Steam Online Kill 2 will be roaming on American time. So it's 2 a.m. not 2 a.m. 10 in the evening. We don't do AM PM here in Iceland. 10 in the evening here on the UTC. I'm not sure what it is on the Pacific time. Carners, do you remember?
Just do UTC. Everyone runs on UTC, bro.
Yeah, Eve time.
Eve time.
Yeah, so 10 Eve time. Steve Online Kill 2 will be PvPing his way around New Eden, probably ESSing like last time, and doing fun stuff. Always awesome stuff. Then we have the Russian Rush Hour for the Russian players on Friday with CCP Alpha. Of course, CCP Deadlifts Dead Space Dawdle on Sunday, and you, Carneros, coming in on next Tuesday on a weekly basis.
We had fun last night. We took Phoenixes on roams, and that was good fun. Thank you to the people who decloaked and let us shoot each other and jump through the T5Z gate. Thank you.
Beautiful. Well, we're ready to start the raid. Pressing buttons, making things happen. Thank you, everyone. Thanks again to the ISDs. Thank you, Explorer, Paradox, and Tuxford, and of course, Carneros, and all you people on chat. Thank you for laughing at my great jokes.